Chapter 5, we're looking at congruent triangles. So section 5.1, we start off with angles of our triangle. Our essential question, how are the angle measures of a triangle related? So we start by going over some of our triangles. Most of these are probably familiar with you. So we can classify triangles two ways, either by sides or angles. So sides, we have three different things. We have scalene triangles, which have no congruent sides. We have isosceles triangles that have at least two congruent sides. And we have equilateral triangles that have three congruent sides. Isosceles says at least two, because technically an equilateral is a special isosceles triangle, even though we won't normally explain it that way. And then classifying triangles by angles. We have an acute triangle where all our angles are acute, okay, which is different than our other three. Our right triangle, we have one right angle. Our obtuse triangle, we have one obtuse angle. And our equiangular triangle is actually also acute. And these are all congruent angles. Right. So realize in your right and your obtuse, two of the angles would be acute. The third one is what makes it that way. So an acute triangle, you have all of them. As we go along, classifying these will need to depend on the right. We need to depend on how it's marked. But some of these we're just going by how it looks. Watch that you're doing both, classifying it by sides and angles. So if I look at A, none of my sides look the same. So I would say it's scalene. This angle looks obtuse. So we're going to say it's obtuse scalene. B, they'll look acute. So I have two sides that are marked congruent, here and here. So we're going to say it's acute isosceles. And then C, the three sides are congruent. So it's equiangular. And we'll get into this as we go along. If it's equiangular, it's also going to be equilateral. So that is equiangular and equilateral. Example 2 basically looks at the hardest type of problem we can see here. With this type of stuff, it asks us, it gives us the vertices, A, B, and C. It asks us to graph the triangle and classify it by its sides, and then determine if it's a right triangle. So to determine if it's a right triangle, we can't figure out, or we can't with what we have, figure out if an angle's obtuse or acute. But we went over slope of our lines before, and our slope of our perpendicular lines are negative reciprocals. So what we do is we check and see our slope of our lines and see if they work. Normally, there's a pair of lines that look like they might be obtuse, and that's the best place to start, because once you show that, or not obtuse, looks like they're perpendicular, because once you show that, then you're good, and you don't need to check the other two. So the slope of AB here and the slope of BC here are the two we're going to look at. So if I look here, I come over 1 and up 2. That gives me a slope of 2. And here I went backwards, so 2 over negative 1. BC, I come over 6 and up 3. So that gives me a slope of 3 over 6, which reduces to 1/2. So those are negative reciprocals. So that is perpendicular. Okay, and that part is done. Then to look at classifying it by sides, and this is the harder part, is we need to look at the length of the sides. Sometimes they're nice, and there's things I can count. In this case, they're not. Now, AB, generally don't want to make this assumption, but AB is clearly shorter than the other two. Okay, so what we want to check, I don't have the C on there either. We want to check AC and we want to check BC. And what we're going to do for that is distance formula. All right, so distance formula, where you're doing subtracting your x's, squaring that, subtracting your y's, squaring that, and adding those together. So I have 6 minus -1 squared plus 3 minus 2 squared. So that gets me 7 squared plus 1 squared. So the square root of 49 plus 1. This is the square root of 50. BC, I have 6 minus 0 squared. This one's nice and easy. 3 minus 0 squared. So I have 6 squared plus 3 squared, which gives me 36 plus 9, square root of 45. I could do the decimal and find out what these are, but at this point I know they're not the same. So AB, we already said, is obviously shorter. So this is a scalene right triangle. Then going to the back, right, defining some stuff on our triangle. So the first thing we define is the interior angles, right? They're the original angles of our triangle, right? Inside here. Exterior angles are angles that form linear pairs with the interior angles of a triangle. So if I have this as 1, 2, and 3 as my angles, the exterior angle, if I extend this out, 4 here is exterior because it's a linear pair with 3. All right, if I come out this way, this would be an exterior angle. If I come out this way, that would be an exterior angle. Okay, and depending on which side you do, if we extend this way, 4 would be over here. As long as you have one angle at each thing, you're fine because those angles will be the same size. You shouldn't have more than one external angle at a corner or at a vertice. Triangle sum theorem, you're probably familiar with this. Measure of A plus a measure of B plus the measure of C, being ABC, is 180. So the sum of the measures of the interior angles of our triangle is always 180 degrees. The exterior angle theorem, you're probably not familiar with, right? It says the measure of an exterior angle, which here is measure 1, is equal to the sum of the measures of the two remote interior angles. So those are the angles that are inside, that are not by angle 1. So in this case, it would be angle A and angle B. Angle C would be connected to it. So A and B are the remote interior. And that works because these three angles add up to 180 and these two angles add up to 180. So these two have to equal that one. Corollary to the triangle sum theorem, right? The acute angles of a right triangle are complementary. That's weird. Okay, which again means we add up to 90. So A plus B will add up to 90. This depends on how you work through problems, whether it's helpful or not. I would use it a lot if I give you A and I ask for B. Instead of adding these up and subtracting from 180, I can just subtract from 90. But that's up to you. You can always add them up to 180 and subtract. Then we get into solving some of our triangles here. So example 3, find the value of x, then classify the triangle by its angles. So here I have 40 and 61. So I add those. I get 101. And then I know the whole thing's 180. So 180 minus 101 gives me that this is 79. These two are acute. That's acute. So my triangle is acute. B, I need to solve for x anyway. But here they give me the right angle. I can just say that it's a right triangle. And then here's where we reference the corollary we just talked about. I can do 30 plus 90, get 120, and subtract that from 180. Or I could just do 90 minus 30, because these two have to add up to 90. And I get that that angle is 60. Then turning the page. Right. Now C is a little bit different. So for C, we're going to set up an equation. They still add up to 180, but I don't have anything I can add or subtract here. And I could have actually done this on the other one, but most people won't do that. Well, so I have x, 6x minus 8, and x plus 4. And you can put the parentheses around these, but there's nothing happening in there, so they're just going to disappear. And they add up to 180. So then I'm going to combine like terms. So I have x, 6x, and x. That adds up to 8x. And then I have negative 8 and plus 4. That'll give me minus 4 equals 180. Watch how you're using your signs here. The sign in front of it is the sign I'm using with it. So it's negative 8 plus 4. Right? Positive 6x, positive x. Add 4 to both sides. Get 8x equals 184. Divide by x. I get x equals 23. Now watch, we go back and look at our instructions. It says find the value of x and classify the triangle by its angles. So I need to know what type of triangle this is. Now I could plug it into each of these, but your best bet is plug it in the one that looks like it's going to be something different. So here, if I do 6 times 23 minus 8, right, 6 times 23 is 138, minus 8, that's 130. So this triangle is obtuse. All right, so watch what it's asking for. Sometimes it may ask for the angles. Here it's asking for the type of triangle. So I need to make sure I'm solving for that. Right. Then example 4 asks us to find the measure of the exterior angle shown. So here, angle 1. So remember, that's the sum of the remote interior. So 80 plus 60. That is 140. Now here, B, I'm going to have to solve for x and then plug in. But same type of setup. Right? 3x plus 6 equals 80 plus x. Because this is equal to the sum of the remote interior. So 2x plus 6 equals 80. 2x equals 74. X is 37 when I divide that 2 in there. So if I plug in 3 times 37 plus 6, this gives me 111. And that angle is 117. That's my final answer. That is looking at our triangle, or types of triangles.